Today I'm working on an Atari 7800 with a serious case of the RF video blues. I'm going to show you how to take your video from this to this. And it's not as difficult or as expensive as you might think. Alright, so in my last video, I took a look at an Atari 7800 that I picked up last year at Midwest Gaming Classic in 2022. It was missing the power adapter, so I took you through the process of how I built one from a really odd flashlight charger that I found online. I ended the video by playing a few minutes of Food Fight. This is what it looked like. It was bad. Real bad. So now it's time to fix that. I'm going to walk you through how I removed the RF modulated video and replaced it with composite output. But before we can go any further, we need to open up the 7800 and pull out the main board. To understand how this whole process works, we'll go through it one step at a time. Now, fortunately for us, the Atari 7800 schematic is out in the wild. So this is going to make this whole process a lot easier because it takes away a lot of the guesswork. So the first step is going to be to take a look at that schematic and get a lay of the land. Here's the schematic for the NTSC version of the Atari 7800. If you take a look at the bottom right, you'll notice this big box here labeled RF1. This is the RF modulator. This circle, which is labeled RF out, represents the physical RF port in the back of the 7800 where your TV plugs in. Now, notice that there's 4 pins for the RF modulator, and those are labeled 1 through 4. These correspond to these 4 pins on the main board. Pins 2 and 4 are connected to the channel selection switch in the back of the Atari. So these decide whether the RF modulator is outputting a signal for channel 2 or channel 3. Pin 1 goes to ground, and as you can see here, pin 3 is labeled C video. Now you can probably guess here that this is the composite video signal that feeds the RF modulator. Now wait a second, are you saying, Ken, that the Atari already produces a composite video signal on the board itself? Yeah, and that's just how RF works. You see, RF modulators don't create the video signal, they take an existing signal and they turn it into a higher frequency that a TV channel can tune into. So if you have a device that can take a native composite video signal, the RF modulator can be removed entirely. So as a next step, I'm just going to remove it, and it'll leave the perfect spot for us to mount the new board with the new composite output jack. So I use my desoldering gun and remove the RF modulator. All right, the RF modulator is gone now, so let's get back to the schematic and see what's next. We know the composite video signal was getting sent to pin 3 of the RF modulator, so that seems like a good place to tap into. Before we do that though, I want to point out something interesting. The 7800 is backwards compatible with games from the Atari 2600, so there's actually 2 different video chips inside. This chip here is the television interface adapter, also known as the TIA. It's the video chip that's used for Atari 2600 games. This other chip over here is the Maria, which is also a video chip. But the Maria is used for 7800 games. Now, going back to the composite video signal, take a look at this series of OR gates. These logic gates will pass through the video signal from either the TIA or the Maria chip. and these are then summed together to form the composite video signal. So what this means is I don't need to worry about combining multiple video outputs. The board already takes care of that itself. So this leads to the next step, which is to pull the composite video signal off the board. So let's tap into this composite video signal and see what we have. Now, to make this easier, I'll solder a test lead onto pin 3 and another one onto ground. And I'm just going to use some alligator clips to connect it to an RCA cable. Now let's plug it in and see what we got. Okay, there we go. As you can see, the video is already much better than it was through the RF modulator. It can definitely be improved though. For one thing, there's diagonal bars going down the screen. So let's take a look at how to get rid of those. To see what's going on, let's take another look at the schematic. Look again at the composite video signal that we've tapped into. If you follow this down, you'll notice that there's another portion of this circuit that's summed in with the video signal. And if you follow the connections, you'll notice that this is getting fed with audio. So the noise we're seeing is actually audio from the game. And this makes sense because RF passes both audio and video to the TV over a single cable. And this leads to our next step, which is to separate the audio from the video. Now the easiest way to do this without doing too much harm to the board is to find a component that's in the path of the signal and remove it. Following the composite signal, here you'll notice that resistor R3 is in the path of where the audio and video signals meet. So to break that connection, we'll just remove the resistor. The labels are actually under the components in this board, but it turns out that R3 is this tan resistor right here. Now the best way to do this is to actually cut one of the legs of the resistor. This has the side benefit of keeping the resistor there just in case you ever want to reverse this mod. Okay, let's go take another look at that video signal. All right, take a look at that. The noise in the signal is gone now and it looks really clean. Now one thing you'll notice though is the video is really faded. Now why is that? Well, to help understand what's going on, I put my multimeter into amps mode to measure the current in the signal. Now watch what happens when I turn the Atari on. The TV is only pulling half a milliamp from the board. So to get a better signal, we need to boost the amount of current. And that can be done with a simple transistor amplifier circuit. And that takes us to step number 5, which is to amplify the video signal. So here we have an NPN transistor, which has 3 pins: the base, the collector, and the emitter. To amplify a signal, you first need to feed the signal that you want to amplify into the base pin. Now, you need something to amplify it with. So we'll connect the collector pin to some other voltage source. In our case, we'll grab 5 volts from the Atari. And then you connect the emitter to ground. The type of amplification you get from this will depend on where you tap into the circuit. If you pull the amplified signal off the collector, then you'd get an amplified voltage. But if you pull the signal off the emitter, you'll get an amplified current. And that's what we want to do here. So let's put it on the breadboard and try it out. Okay, I built out the circuit on the breadboard. This is really simple. There's only 2 components here. The NPN transistor, which in my case is a 2N3904, and a 2 kilo ohm resistor. I pulled 5 volts from pin 2 of where the RF modulator used to be, and connected that to the collector pin. That's the white wire here. And I have the RCA jack pulling the video signal off the emitter, and that's through the black alligator clip. Okay, let's fire it back up and see if we can pull more current now. And there you go, we're pulling 9 milliamps. So now let's take a look at the video. And it actually doesn't look any better, but it has changed. Here's a comparison of the before and after. Now this is a little deceiving because it doesn't look like we've boosted the signal at all. But that's not true, we saw it on the meter. If I pause here at the title screen, you can get a better idea of what's going on. Notice how the letters at the bottom were yellow before, and now they're almost white. It's almost like the brightness of the TV has been turned all the way up. Okay, so what's actually happening here is in the process of boosting the signal, we've modified the composite video data. To understand what the root cause is, let's put it on the oscilloscope and take a look. So here I have the yellow probe connected to the video signal before it's amplified, and the purple probe is after the signal goes through our amp circuit. So let's pause this and zoom in. Notice that the amplified signal doesn't have as deep of a valley here. Now, if I overlay them, you'll see that our amplified video signal is clipping this video data. And the reason this is happening is because the transistor has a minimum voltage of around 700 millivolts before it's turned on. So the way to fix this is to get the entire composite video signal into the active region of the transistor. And we can do this by adding a couple of volts to the video signal before it goes into the base of the transistor. Now this is a pretty common process when you're building an amplifier. In fact, there's a name for it. It's called biasing the transistor. The easiest way to do this is to add two resistors to create a voltage divider at the base. These resistors will set the voltage to whatever we want as long as we select the right values. So we'll feed the first resistor with 5 volts, and the second resistor is connected to ground. Now we want to add somewhere around 1 to 2 volts at this point. That'll bias the signal enough to move it all into the transistor's active region. To figure out which values to use for these resistors, I'm going to use the voltage divider calculator on the Texas Instruments website. I like this one in particular because it'll suggest a number of options for different resistor combinations. That way I can go through my box of resistors and see which of these I already have. The input voltage is already set to 5 volts, so we'll leave that alone. But I'm going to change the output voltage to 2 volts. And I'm changing the resistor series to E24, which will use a larger number of resistor values. The calculator spits out a few different options for us. I know for a fact that I have some 3.3 and 2.2K resistors in my parts bin, so I'm going to go ahead and go with those. But really any of these combinations would work. All right, let's add the voltage divider and try it out. Okay, let's turn it on and see what we got. All right, that looks much better. Here's what it looked like before adding the voltage divider so you can see the difference. By the way, that band of color distortion you're seeing is just noise from the breadboard. It'll go away when I move the circuit onto a more permanent place on a piece of perforated board. Okay, this is great. We now have a clear composite video signal, but we're still missing audio. So the next step is to figure out how we're going to pull audio off the board. Okay, back to the 7800 schematic. Remember that earlier we separated the audio from the composite video signal to clean it up. Normally, audio is produced by the TIA chip, so you can see the audio signal coming from the TIA here. But also notice that there's another audio signal that gets added in, and this is labeled E-Aud. If we trace this connection, you'll see that it's coming from the cartridge connector. This decision was probably made to cut costs. The 7800 had a great new graphics chip, but it still used the same audio chip that the 2600 used. So Atari gave developers the option of including a better audio chip inside the cartridge. Now, only 2 games did this, but I do want to include both of these audio lines in this mod because I have one of these games and I really want to play it. Now, I tried to find a spot to pull the audio signal after it was combined on the board, but it just wasn't going to work out without some additional components. So I gave in and decided to pull the audio lines individually and add them together myself. I found that the best place to take the signal from is this spot right here. Notice, by the way, that there's 2 different resistor values for both audio lines. The sound coming from the TIA is louder than the cartridge audio, so I ended up putting a 6.8K resistor on the TIA line to even out the volume difference. Now, with audio figured out, we can now add it to our mod. We'll have 2 audio lines coming in from the board. The line coming in from the external audio connector will just go straight into the audio output. And the line coming from the TIA will get a 6.8K resistor to lower the volume. All right, that should be everything. So the last step is to transplant it onto a piece of perforated board and install it in the Atari. And here's what the board layout will be. This piece here is a standard 3.5mm audio jack. I'll wire it up so it puts out video on the tip of the connector and audio on the ring. To mount the board in the Atari, I used some standoffs in the holes left over from the RF modulator. With the board done, it's now time to install it. There are 5 wires that need to be connected. The red and black wires are power and ground. The yellow wire is for composite video. Blue is external audio and green is TIA audio. All right, I think we're done. So it's time to put everything back together. Well, after all that work, it's finally time to try out this system. I have the Atari 7800 hooked up here to this monitor, and we're gonna go ahead and try out Food Fight first. This was one of the games I used for testing. So let's see how it plays. Okay. Wow, it looks pretty good. Well, let's see how it sounds. It sounds not bad either. Oh no! Don't get me. I don't know why. I thought I had a banana that I could hit him with. Okay, Food Fight looks great. Plays great. Wow, that's awesome. All right, next we're going to take a look at Ball Blazer. So if you'll recall, this is the cartridge that has an external audio chip. Here it says it is a Super Game cartridge. So our mod is actually pulling the sound directly off of the cart connector and then putting it into the RCA jack. So let's take a look and see how it sounds and plays with Ball Blazer. Okay, the video looks good and the audio is at a good volume as well. Let's try out a game. Okay, looking pretty good. And then lastly, I'm going to try an Atari 2600 game. So this is Dig Dug. So we're going to see how 2600 game sounds. Okay. Got him. Cool. Oh, there's two of them there. I didn't see that. Rats. There's still two? Yeah. Okay. Let me use a different strategy here. Oh, he got me. Oh, man. Okay, wow, that looks good too. All right, well that's all I have for now. I hope you enjoyed this look into how I did a composite mod in this Atari 7800. I really enjoyed making this video today, and I hope you enjoyed watching it. So until next time, go make something cool.